Hello and welcome. I'm Casey Muratori, and I'm doing a series of cryptocurrency interviews with people who know the technical details so I can basically ask questions about exactly what they think of the technical details of it. Do they think these technical details are important? How do they affect things like whether cryptocurrency will do a lot of the things that people claim it will do, and all that good stuff. So, this interview today, my guest is.
Amaury Séchet.
And Amaury, could you give us a little bit of a sort of a reasoning why you're into cryptocurrency, or why you started looking into this stuff or learning about this stuff, and why you agreed to talk to me today?
Yeah, so, well, even though I'm a software engineer, I was initially interested in cryptocurrency, not for the technical aspect of it, but more for the, freedom-oriented aspect of it, because, I, I've always been like interested by personal freedom and stuff like that. And one of the big threat generally on freedom that I've seen around is that you have those big companies through all the through which all the transactions go through, like Visa, MasterCard, or this kind of entities. And even like 10 years, it's quite funny. 12 years ago, I did an interview with Le Monde, which is like a big French newspaper. And they were like, about privacy and stuff like that. And people were very worried about Google and Facebook and stuff like that at the time. And well, there still are now. And there are some reason to keep an eye on it. But one of the things that I was saying at the time is that actually like payment processing was even bigger of a deal, right? Because the information that they have is literally what you value, right? Because Facebook and Google, they have what you give them, which is quite a lot typically. But, for instance, they cannot know something that you don't know about yourself. Whereas actually, if you wanted to know yourself better, having all the information that Visa and MasterCard has on you would be, because you're like, I think I value this and this and that, but where am I actually spending my money, right? And you can see like what you actually value, not what you think that you value. So those people have very interesting information about you, and they also have the capability to, to block transaction or stuff like that. So that happens in some cases for political activism, like we saw that for WikiLeaks many years ago, for instance, where effectively a call payment processor stop processing payments to them. But actually happened like to me a few times because I worked in many different countries, and so I had to deal with a lot of international banking. And so maybe that's a case that is not common to everybody, but typically within the country you have like your framework that is well established, but as soon as you start doing international banking, it starts to be like very wonky. And so all of that combined, I was like, surely we can do better than if you want to move money from Japan to France, for instance, it takes like a week, and then you have no, like, it goes through like 5 different banks, and you have contact with both at the two ends, right? But you have no visibility on what's happening in the middle. And quite interestingly, like people at the end have no visibility either, right? So all of that were like, there must be something better. And when you think about it, what it boils down to is that you need some form of digital cash, because there is a technology that we don't have online that is cash, right? Like it seems so stupid because we're used to it, but if you do something for me and I pay you cash, there is no intermediary that is involved anywhere, right? And before cryptocurrency, this just was not possible to do online. And all those intermediaries, they bring a lot of like privacy concern, risk concern, censorship concern, and they effectively like have a pretty heavy control on your life. So that's the end goal. I went at it. I was in like fairly early on. I learned about Bitcoin in 2010. So, not the earliest, but fairly early versus most people, let's say. But at the beginning, I was like mostly on the side because I followed like previous, maybe people are not so familiar with that, but there was previous attempt before Bitcoin to do digital currency, and many of them ended up pretty badly for the people who started them. Because um, you're not supposed to create your own form of money, right? Like
Yep.
that's something that is reserved for governments and stuff like that. So
Yeah.
depending on where you live, you're gonna run into a lot of legal trouble if you do that. And that happened to several people before Bitcoin, and it's probably why Satoshi Nakamoto, remained completely anonymous to these days.
Right. Right.
Um, but like considering that, it was not like it is today where everybody is talking about Bitcoin. At the time, that was very niche, and
Yes.
and the like the context was that it was potentially dangerous, right? So
Yes.
I didn't went super public about it at the time. I got more involved though on the technical aspect of it around 2014, 2015, because this is when these things became big enough so that scalability was a problem. And this type of problem is much more the kind of problem that I know how to solve. Like I'm not a cryptographer, for instance, right? So
Right.
if you
Yes.
ask me to roll out new cryptography, like I'm not the right person to ask that. But like distributed system and scalability concern and databases and stuff like that are stuff that I'm fairly familiar with. And so those questions started arising. And at this point I got involved like more on the technical front. So that's a bit my story with crypto. And
So
since then, I mean, I should say, like, since then, I created BCH with like top 4 for a while. Ever since I left, it dropped to top 20. So I don't know, like, if correlation is causation, but I like to think it is. And since then, I created another project called eCash that, as the name indicates, the goal is to create an electronic form of cash.
I guess what I would say is, at least broadly speaking, so that people know sort of where I'm coming from, I am 100% on board with that sort of goal that you stated originally, because it does seem to me like there's a great deal of risk currently associated with money. Meaning, if you want to take somebody who is disfavored, or who, for whatever reason, the government or a majority of the population frowns upon, the easiest place these days to, attack them is actually their money supply. Because for whatever reason, we seem to have very strong laws in a lot of, at least Western nations, have these laws that protect other aspects of your life, but very few places in the world have any kind of strong legal protections for your monetary well-being. Oddly enough, right? Like, your ability to accept payments in a modern world is strangely unprotected in most
Mm.
places. Like it doesn't really matter where you live. It seems like it's pretty uniformly the case that it's just not something that you're guaranteed as a right for whatever reason. Possibly because before the advent of things like internet, you know, uh, they weren't thinking about these as being risks when, countries developed their legal systems, I assume.
Yeah, well, my assumption is that, like outside of the world of internet, you still have cash, right? So if
Exactly.
if nobody wants to open a bank account for you, you can still stack your banknote,
Yes.
somewhere at your place and pay stuff with cash, right?
Yeah.
So it's probably still annoying. You would want to have some of those financial services, but you can go by. But as more and more stuff move online, that becomes more and more of an issue.
My main so really, like, I don't have any questions around that, because I just assume that, most people can probably see why there's at least risk there. Maybe they don't agree that that risk should be mitigated, but we've seen enough
Mm-hmm.
examples now that it seems sort of self-evident that, like, if it was something that would concern you, meaning if you were concerned about the fact that people can take away other people's ability to accept money, more or less with no real legal constraints on doing so, then there's a reason why we might want an alternative. So, really, the questions that I want to ask are just more about, how does cryptocurrency actually provide an alternative to this? And hopefully, you can understand the thrust of the questioning. I'll just start off with a sort of broad question about it, which is, in general, cryptocurrency, the design of the underlying systems, they tend to produce just generally a consensus algorithm for where the cryptocurrency went. That's more or
Yes.
less all the technology actually does. And so
Well,
unless
yeah, there is more to it, but that's the piece that is very interesting. Like all of it around it is like scaffolding that makes it work.
yes, and so I guess the broadest point I'd like to start out with, and then we can start to drill down on if there's something that I don't quite follow why it would be the case. My main concern is just why is the end game for crypto any different than the end game for anything else? Because in general, you will always still have to take whatever that consensus is and turn it into something in the real world. And at that point, why doesn't all the same things that we see today with our current currency system also apply? The government regulation, the fact that there will be large actors who control significant sectors of whatever that conversion is, the fact that people might renege on something that they agreed to do in the real world, all of these factors. I don't quite see how the end game for crypto ends up anywhere different than the end game for what we already have. And if there's some reason, if there are some actual hard technical reasons why it wouldn't, those are the things I really want to focus on. So does that question make sense? And can you elaborate on that a little bit?
Oh yeah, that's a fantastic question. Though maybe we want to break it down a bit, but
Please, yes.
one of the things that you point out is fantastic, because this is where I probably diverge from a part of, let's say, like the more mainstream part of the crypto ecosystem, because
Okay.
what you describe is what I'm seeing happening with Bitcoin, for instance, right?
Really?
So
Okay. Yes, please go. This is exactly what I was hoping to hear. Please go into detail.
yeah, so Bitcoin has limited scalability on chain, right? And so
Yes.
people have been developing solutions to work around that problem, where you can do stuff that are off chain. And one very interesting thing is, like, doing so, they are kind of rebuilding the existing system in worse.
That was my exact, like, are you talking about like Lightning Network and things like this?
Yes,
Yes, that
yes.
was my read on it as well. I'm okay, great. Please go into
Because
detail on this. This is exactly what I was hoping for. Thank you so much.
yeah, so what happened? Like, if we want to understand that, maybe we want to understand a bit how the current financial system ended up being the way it is. And obviously, like, I'm gonna grossly oversimplify everything, because,
Certainly, yeah.
but so at the beginning, people use like precious metal and stuff like that to trade, because they have good monetary properties, but they are not very convenient to use on a day-to-day basis.
Right.
And as the scale of the trade increase, it's also much more inconvenient, right? So if you are a sailor around the Mediterranean and you trade between, say, Egypt and Italy or something like that, you don't want to be like carrying your gold on the ship
Yes.
every time you go back and forth, right? So what happens is that at some point you are gonna deposit your gold to what is effectively a bank, and then you're gonna like withdraw from the bank on a per needed basis. So that's the first iteration of it. And the second iteration is like, once you have banks that have been there for a while and that people trust, they can start to emit like certificates that, oh, like, this dude owned that much gold, and then instead of trading the gold, you can trade those certificates instead. And so the person that has the certificates at the end, can redeem the gold eventually.
Yes.
And so that works great, except you have horrible liquidity problems when you do that, right? Because there is not like the right amount of gold in whatever banks, and then you effectively like abstracted one level, but the banks end up having the problem that you were having before, right? They need to transport the gold around and all of that, and so that's somewhat more efficient, but that's not that much more efficient. That's more practical for the people trading, but the overall system is still pretty inefficient. And so this is when people start to go fractional. And this is probably one of the paths where I diverge to most of the crypto ecosystem, because I think that going fractional to some extent is more or less necessary for the efficiency of the system, right?
Gotcha.
Because otherwise you have liquidity issue.
And could you just, for the folks who are listening to this, who maybe haven't thought about this stuff very much or haven't read about it, can you just explain the concept of fractional? Just like, because it's pretty fundamental to not only crypto but general finance. Just so, yeah. If you wouldn't mind, yeah.
Yeah. So the bank have a certain amount of gold and emit certificates for it. And when the banks goes fractional, effectively it's when they emit more certificate than they actually have gold in their vault.
Yes.
And because not everybody is redeeming the certificates at the same time, it actually works. Granted, the bank needs to calculate, what is the risk and all of that. There's
Yes.
like all kind of financial questions that are on that.
Yes.
But going fractional to some extent actually, helps liquidity, right? Because if the gold is in one bank and you need it in another bank, then because not everybody is going to redeem, you can start emitting more at the other bank and, in the background, transfer the gold whenever, right?
Yes.
And so yeah, at some point you kind of have to go fractional because, well, if you're not going fractional as a bank and your competitor are doing it, then you're gonna have liquidity problem and they don't, right? So everybody is gonna go to your competition. So at some point, it's just more efficient to do it, and you cannot really work against that.
So that's actually a really good point. I'd never quite thought about that aspect of like fractional reserve banking. Once somebody starts doing fractional reserve banking, pretty much everyone has to do fractional reserve banking because otherwise you will just get out competed. Because they can leverage the fact that there's a certain default rate on risk, they will just be able to offer better services effectively. I mean, is that a fair statement?
Yeah, and the trade-off that they are making is that maybe the bank go bust, and
Yeah.
then some of those certificates cannot be redeemed,
Yeah.
right? That's the counterparty risk, and a lot of the people in the crypto space, they're like, oh, fractional reserve is completely evil and we need to ban it completely.
Right.
But if this was done transparently, that would probably be better, right? So you probably would have
Yes.
some banks that be like, we don't do any fractional stuff. That means that some of those services that we serve you may take longer or whatever, but that whatever happens, if we go bust, we still have the money to pay everybody, right? And maybe there are other banks that are like, oh, we can like deposit your money right away and stuff like that. Because it's a bit of a segue, but think about it. Actually, a credit card transaction, for instance, takes 2 to 3 months to settle, typically.
Yes.
Right?
Yes.
So if you didn't have fractional banking, when you pay with your credit card, the merchant could just have the money like 3 months later, not before than that, right?
Yeah.
This is the kind of problem that you would have.
Yeah.
So there is actually huge value, like being able to pay by credit card and have the merchant at the other end receive the money, like maybe the next day or fairly quickly. So there is a certain amount of risk, right? But at some point, probably there is too much risk and people wouldn't want to do it. So maybe doing it transparently would be a better way to do it right now. I don't think banning it right is. So anyway, if we get back to
sorry to derail that there, but I think that was great because it's something that it's important to understand. So yeah, please, you had gotten up to fractional reserve banking in like the history of banking. So yeah, go from there.
Yeah, and so obviously, well, it works better, but there are several risks associated with that. The bank can go bust. Also, one bank can just go crazy and start emitting like a crazy amount of currency. So right now, all the banks are usually there is the central bank in the country that limit the various banks' ability to do that or control it in some way. Obviously, the details of that are going to depend of each country and each currency, but there is a variation of that pretty much everywhere now. But still, it happens on a regular basis that the central bank just go like completely mad. And those problems, they are not theoretical. Like maybe people in the West, like in the US or in France or whatnot, they are not so used to that. But just this week, for instance, all the bank closed in Lebanon. And I'm not sure what the situation is right now, if they reopened or not, but like just imagine the total mess that this creates, right? And this is what happens when there is a bank, what is called a bank run. It's like when too many people try to redeem the money from the bank that is fractional, right? And so that the banks doesn't have the reserve to, redeem everybody. And when that happened, then, well, there is no money, right?
And
there is no money to go around.
I mean, that sort of thing has happened almost everywhere we've had banks. I mean, the U.S. had.
Yes.
That's why we have FDIC insurance, really, in the U.S., for example, is because we had bank runs, right? That's just something that happens when if the populace if the populace's faith in the banking system, either locally or widespread, is shaken at some point, people will want to get their money out because they're afraid, they don't want to be the last person, right? To try and
Yeah,
go
that's
get
the
their money,
problem, right?
right?
When
So
that starts happening, then
yes,
the incentive for everybody is to do it as soon as possible.
yes, and they're not wrong, because usually a lot of times this fear is well justified, but of course the fear itself actually also produces the problem. So it is a really severe issue with that.
Yeah, so yeah, it happened in Cyprus in 2012.
Mm-hmm.
It happened in Lebanon last week.
Yep.
It happens in many places. Actually, the average lifespan of this type of system is 27 years.
Oh, okay, great.
so the US dollar is like way past you
Yeah,
having
yeah.
like a major problem.
Yeah.
But it's not completely random as
Yeah.
well, right? Like it's the average, right? So
Yeah.
the ones that are better managed are gonna last longer, but still that's a remarkably short time, right?
Yes, yes.
So anyway, the root cause as to why this happened is because the technology that have soon hard monetary property, meaning like they are scarce and fungible and whatnot,
Mm-hmm.
Are different from the technology that are convenient medium of exchange.
Okay.
Right. So you end up having this impedance mismatch, and you have like all the system that we have is actually at its core made to like, patch over the impedance mismatch between the two.
Okay. So
right, because you cannot do that with gold. Like this kind of problem cannot happen with gold, but it's just not convenient to use gold, right? Like you would go to the shop and they're like, oh, this is like 0.3 gram of gold, and then like what do? Like you chip a bit of that would be like completely impractical. And how do you do it online? It's even more impossible.
So yeah, to bring this back to the original question.
Yeah.
So yeah, like how does cryptocurrency avoid exactly the same fate? Because again, like my biggest concern when I look at the underlying technology in general versus the claims that people make about the benefits to it, a lot of what I'm missing is I don't see how it doesn't have all the same eventual problems, assuming that you're able to get to the point where it can actually handle significant amounts of the world's economic activity. I'm not seeing the explanation of why you don't have the exact same problems with it. And so far, your explanation
no, exactly.
seems
I
to
think
support
you're right.
that, so.
I think you're right. I think
Oh, okay.
the condition under which you don't have the same problem is if you have a system that is large enough so that those that impedance mismatch effectively doesn't exist or is greatly reduced.
Okay, so maybe let's go down that route then. So what are the differences with and for talking about this, go ahead and either pick a cryptocurrency or imagine the cryptocurrency that you would want. And so you don't have to talk about, specifically Ethereum or specifically Bitcoin if you don't think they actually satisfy the properties that you need.
Mm-hmm.
But assuming an optimally designed cryptocurrency with technology that we have and know how to do, can you sort of talk about why there wouldn't be the same kind of impedance mismatch?
Because granted that, like the major technical hurdle here is scaling, but if you can scale something big enough so that it can do TPS that are comparable to stuff like Visa or MasterCard or Alipay, or like Alipay is actually bigger than Visa and MasterCard.
Sure, I'm sure, yeah.
But if you can reach TPS that are, in the same ballpark as those entities, then you effectively don't need the intermediaries anymore. And that doesn't mean that they're gonna disappear. Like maybe they're gonna stay around, but if they stay around, then they have to provide value. They cannot stay around because there is just something that is not working properly with the system. And right now, the thing that is not working properly is, with the system is that I cannot transact conveniently with hard money. right? So cryptocurrency have hard money properties, like hard caps and stuff like that. They are relatively fungible and everything. And even if it turns out like something like Bitcoin is not fungible enough, then like there is eCash and Monero and whatnot that are even more fungible. Right? That's there are questions like is what we have right now is fungible enough for that to happen? But we know that if it's not, like the technology to make it more fungible exists. So that's not the major. That's not a major question. So those stuff already have the hard money property. If you can make them as well a good medium of exchange at scale, then you don't need this whole, oh, I'm going to hold hard money for you and start emitting certificates and trading the certificate instead of the money and going fractional. Like, this whole chain doesn't have a reason to exist anymore.
So I guess the question, though, would then be to drill down on that. Technologically speaking, how would we end up with a system that so I guess I might ask a question here because it sounds like so far you haven't really said much about the decentralization aspect of things, but I'm assuming that it's implicit in what you're talking about because you started from a place of sort of assuming that censorship resistance was important because we both talked about the idea that, people can have their money supply, their ability to set payments taken away, and that's probably a bad thing if it's too easy to do, right? I mean, maybe in certain select circumstances, if the government goes through a lot of hoops, maybe you want them to be able to do it if it's like some really bad situation. But in the general case, maybe you.
I don't even think that is the case that much.
Sure. So maybe you don't even go that far, but I just mean in general, I would think in a lot of cases we've seen evidence that it's way too easy for them to do it right now. It's too trivial. So
and not even just for the government, like way often the banks just decide, like
yes,
if you are like a profile that is somewhat suspect or whatever, they're just gonna say no, we don't want to open a bank account for you or provide you those services.
And not even necessarily for ethical reasons. It might just simply be because they think you're too high of a risk and they don't want to deal with you, right? So there's any number of reasons they might just say no, we don't want to.
Well, I can be open about that. Like personally, ever since I'm involved in crypto, several banks
Okay.
I've refused to provide services to me. So thankfully, not all of them. So I can still, like live normally. But like I've not done anything illegal. I've not been condemned or any of that, right? But it just decide like, okay, this guy is linked to crypto. We don't really know much about it. We don't really care. We just don't want to get there. And they say no. That's it.
So, bringing it back to the technical aspect, so let's try to zero in on this part of it because this is the part that I don't quite see. So, what is the technology that you think, and technology is probably a dumb term. Let's, that sounds like something that Wired Magazine says. So, what specific algorithmic qualities or what specific things that you've seen do you think will allow some cryptocurrency, whether it exists today or not, to be able to provide both the benefits of hard money that you're talking about, which is that we know exactly how much is in circulation and who controls it? What will provide that and high transaction throughput? Because so far, that's been something that it's unclear. I haven't really seen a lot of people claim to be able to do that in a way that I felt was convincing.
Yeah, I don't know, because when you look at the number, those TPS, they're pretty big, but they're not that big, right? Like Visa is like a few thousand TPS per second, right? So that's a big number, but that's not an unbelievable number. Like you can probably do that on a rack of machines with like decent software. So it's not unbelievable. And if the cost to pay to be part of that system, like not an actor that just look at it, but like a participant actor, is a rack of machines somewhere. And with that, you can process like the economy worldwide. That sounds like a reasonable enough trade-off to me. So there are different technology right now in the space. Some of them scale better than others, but actually the UTXO model of Bitcoin scale pretty well. It has fairly nice properties. So like, I don't know how much we want to drill into this, right? But at the core of Bitcoin, there is what is called the UTXO set. So it's effectively like a key value pair database where, well, the key is a hash that identify, the entry. And the value is going to be like an amount of money and a script, or like, the condition under which you can redeem that money, right? So it's effectively the balance sheet of the whole system, with, identifier and how much money and
Yes.
what is. Most of the script are going to be, you need to provide the signature with the following public key to spend those coins, right? Like that's what 80% or maybe even 90% of the scripts are, but you can do like more fancy stuff. Anyway,
yes.
So one cool stuff is that, contrary to an account-based system, like would be a bank or like would be Ethereum, those UTXO, they are not like an account. So when you spend UTXO, you make a transaction, and each transaction has input and output, right? And all the input are going to be all the UTXO that you spend.
Yes.
And those UTXO are gone.
Yeah.
And then you have a set of output, which is where you send the money that were in those UTXO previously, right? So you destroy and you create UTXO, you never modify them. So from a database perspective and also distributed system perspective, there's a lot of simplification that happens there. And for the rest of it, like it's a key value store, right? So you can shard, from that ID to that ID, it goes in that database. From that ID to that ID, it goes in, that other database. So that is not that difficult to scale. No, there is one thing that is more difficult to scale is the consensus algorithm itself. And there is also another aspect that is more social, right? So in Bitcoin, there is this strong culture of we don't change anything, right? And because you don't change anything, you cannot change stuff in a way that it scales better. Which is interesting, right? Because you have this system that technically scales fairly well, but culturally, the people in that ecosystem don't want to. And Ethereum is the exact reverse, because it's an account system and you have a global state in it that each transaction can interact with. It's way, way, way more difficult to scale. Because one other aspect of the UTXO set is because you destroy them and you create them, you never muted them, then there is no order in question about this whole system, right? Whereas Ethereum has global state, which is useful when you want to write more fancy smart contract, but it's a nightmare to scale. Because now everything is mutable, and so everything needs to be ordered. And it's very difficult to prove because, it's code, right? So you need to prove that different piece of code actually cannot interact with each other, and proving that is pretty much as difficult as running them sequentially.
Well, it's sort of like a multi-threading programming problem at that point, because if you assume that a piece of Ethereum code can access the information about any particular account, then that basically creates a race condition with any other piece of Ethereum code that does that. So now you are in a scalability problem that is exactly like trying to scale any hard distributed computing problem, right? Whereas you don't have this with Bitcoin,
Well, the properties of it makes the problem much simpler. So, but the Ethereum community is working very hard on scaling stuff. So that's a bit of a weird cultural artifact there that I think is worth noting. But if you start from something that looks like Bitcoin, that means you're going to have less smart contract capabilities, but you're going to have much better scalability properties. Then the last, like, in terms of database and all of that, it's not that big of a deal if you consider that, you are ready to have a rack of machine or whatnot. The consensus algorithm is a bit more of a problem for reasons that are not obvious. But the way Bitcoin works is that every 10 minutes on average, someone produces a block. And in the block, there is the list of transactions that are considered to be confirmed by the system. And this is necessary because I can make a transaction that sends you money. I can make a transaction that sends someone else money. And those transactions, they're going to propagate on the network, not to everybody at the same time. And so some people may see the transaction where I send you money first, and some people may see the other transaction first. And, one of the two is going to confirm and not the other, right? If the system is built properly. And it turns out that this is actually an impossible problem, mathematically speaking. There is a proof that is from 75 about that. So that predates Bitcoin by quite a bit. And where Bitcoins and other cryptocurrency system work around it is that they make it exponentially less and less likely that the ambiguity remains, which practically speaking works, but like mathematically speaking is still not solved technically, in the so anyway,
is this, just to drill down that, are you basically talking about the two generals problem, or are you talking about something else there?
Yeah, it's the two general problem. So there is a proof from 75. I don't have the name of the paper in mind right now, which is a bit unfortunate. But there is a proof that, effectively like simplify the problem to its most basic tenant. So you have like a set of participants that don't trust each other, that need to agree on the Boolean. Like, is it a 0 or 1, right?
Yeah.
Like, this is the most basic, version of that problem. And they are able to demonstrate that it's not possible if the set of participants is, open and they don't trust each other.
Right.
So that's a bit of a problem, but you work around it by making exponentially unlikely that it happens. And the way Bitcoin does that is that you produce block, and still you can have two blocks that are produced at the same time, right? But then on top of each, another block is going to produce, and the likelihood that you have two chains that like continue that way is vanishingly small, past a few blocks, except if the block propagation starts to get close to the interval between the blocks, right? So on Bitcoin, the parameter is that there is 10 minutes on average between the blocks. But if propagating a block takes 10 minutes or even more, then there is no convergence possible of the network. You're going to have like it's not going to make a nice chain of block. It's going to make like a tree where everybody goes in some direction. So you need to be able to produce the blocks and propagate them in a time that is negligible compared to the interval between blocks, right? Because it's very easy to see why if you are 10 minutes and above, it doesn't converge at all, it doesn't work anymore. But you actually start having problem before that. So first, before that, then like the probability doesn't decrease quite as fast, which cause confirmation time to take forever. But even before that, you have a fairness problem in the block producers that cause the system to centralize, right? So what happened is that if you're a miner and you produce a block, and by the way, for that to make sense, people need to understand when you produce a block, you get a reward for that.
Yes.
And so
that's actually why they call it mining, of course, is because producing a block that, for people who aren't super familiar with how these systems work, I guess we should just mention, when you produce one of these blocks, effectively, and underlying all of this also, in case people don't already know, there's never a problem because everything is cryptographically signed by the person spending the money. The question is never whether somebody actually authorized the transfer. That's pretty much guaranteed unless you break the cryptographic signature. The only reason for any of this stuff is that the person who does rightfully hold the money might try to sign it to two people at the same time, effectively. And so you need, it's called the double spend problem, and that's this entire thing is just for that. If you didn't have to solve that
Yes.
problem, you'd never have a problem because any transaction that showed up would be valid because it's cryptographically signed by the person, and until they get hacked, you don't have it. So there's other problems you can talk about.
Yes.
There's social problems like, keys getting stolen and that sort of stuff. But from the perspective of system design, obviously, like, did the person mean to make the transaction is basically a solved problem thanks to the fact that no one's broken cryptography yet. And, maybe quantum computers throw a wrench in that if we have them someday, whatever. But for the time being, that works. So in this particular case, there's two things that happen every time that a cryptocurrency block gets produced. One is that you're trying to put all of the transactions that we're now going to consider to actually say happened. And the other one is that we're going to give you a reward for doing that. And that's the mining part, which is some new cryptocurrency you can spend. And by the way, none of this actually means that the block is even accepted, because obviously the miner could put a bunch of fraudulent crap in there, like transactions that they're invalid, and the cryptographic signature on each of those transactions, when you broadcast the block, it's the responsibility of the other nodes in the network to look and go, hey, that signature doesn't match. This is a fraudulent block. We're not going to accept it. So
Yes.
sorry, I realize we never said that. So for people who don't,
No, you're correct.
So anyway,
it's gonna be difficult for people to follow. Like, I'm kind of assuming knowledge in what I'm saying,
and I don't know how much people do or don't know when they tune in. So just quick one there. And if you don't understand this, there's plenty of resources to read about. But that's basically what we're talking about. Okay. So anyway, continue from the mining part.
Yeah. So exactly. So when a miner produces a block, well, they have the block right away, right? They just produced it, so they can start mining on top of it right away.
Yes.
Whereas other miner, they're gonna have to wait for the block to propagate to them before they can mine on top of it.
Yes.
Right. And what's gonna happen quite often is that first the header is gonna come to them, and then the content of the block, right? Because the header is only 80 bytes, at least on Bitcoin, but it's generally very small anyway. Yeah. So it arrives very, very quickly, but then you need to download the whole transaction pack, right? Yes. And verify them all as you mentioned. So what's gonna happen is that, the other miner, they lag behind, right?
Oh,
and so right?
Yeah.
Because they need to wait for the block to arrive to them so that they can start mining on top of it, right? So they have some time where they are mining on top of a previous block that is, not worth mining on top of anymore. And so what happens is that the person that produced the block has a small advantage over everybody else. And that advantage depends on the ratio of the block propagation over the interval between blocks.
And I guess a thing I had never thought about till you just said it, because obviously I don't work on these systems, so I've never had to really consider attacks. Do some miners attempt to slow down their transmission of the contents of blocks for that very purpose? Or not really, because game theory-wise, I want someone else to produce something on my block first to avoid someone else from sneaking a block in the meantime, or like how to... But presumably there's a little bit of lag you would want to insert for optimal game theory, which is like, I know I got the hash first, and on average, the amount of time till the next hash hits is this much, so I should delay the block send by a little bit. Do you know what I'm saying?
Yeah. This is an excellent question. And actually, this is a very good question. The second most quoted paper after the Bitcoin Mice paper in the cryptocurrency space is about that.
Really? Okay.
Yeah. So it's paper, like, it's called selfish mining. So the paper is like,
I can put links in the description too if you want to just send these to me. I can paste them in so that the viewers can click on the link when they watch this on YouTube or whatever.
Yeah, so I can't remember the full name of the paper, but the idea that you describe is called selfish mining, and there's a paper that described that, and that is like the second most famous paper in the space, where there is a whole strategy of like, do you want to withhold your block or do you want to publish it? And actually you can increase your profitability by screwing with the system a bit.
Yeah.
Now there are, I just have it there.
Now,
so it's called majority is not enough, Bitcoin mining is vulnerable, and they describe a strategy called selfish mining in it.
Which isn't really a problem, because you would assume that everyone just applies whatever the selfish mining algorithm is, and we're back to normal. But it's just it was an interesting
well,
thing,
no,
right?
because it's not symmetrical, right? Like the person that produced the block has an advantage, and as a result, they're going to start producing more blocks, which gives them even more of an advantage, right? So there is a runaway situation where the whole system collapses toward one actor producing everything. And this is the problem. And this is why you want to have your propagation time to be very small compared to your interval between blocks. Because, well, if you don't have the case, effectively, like economically, your system has to collapse where, to one block producer. And intuitively, intuitively, you would understand that, right? Because if the system was completely fair, meaning like you have that much percent of the hashing power, you get that much percent of the block, then you wouldn't have 51% attack, right? Because what happened is that if you have more than 50% of the hash power, you can just not mine on anybody else's block, only yours. And your stuff is gonna grow faster than everybody else, right? So the actual curve is something that goes to 100% when someone owns 50% of the hash, right? So clearly it's not linear here. But the mathematics are not that complicated, but they are not that obvious as well. Like, well, anything related to probability and game theory and all of that can be extremely counterintuitive. So even though the math is not that difficult, like putting the equation in the right way and solving them in the right way is important to understand. But yeah, there is a non-linearity there. And well, the whole stuff works. For the whole stuff to work, you need this propagation time to be very small, which obviously, like, this whole discussion started with scalability, right? So obviously you have a problem with scalability here, because the bigger your block, the longer the propagation time, obviously. So what are you gonna do, right? That's where you have, I think, an actual interesting problem. And there are a few areas of exploration, and I cannot, I can tell you the one I believe is the most promising.
Second, just 1 second before I go there. I also kind of want to point out here, just to see if you agree with me on this, is the difference, as you were stating, between the time it takes to propagate a block versus the time that we expect new blocks to be produced. The time that it takes, and that second one has to be significantly larger, because, like you said, as they approach a similar amount of time, this kind of consensus algorithm falls apart. Now, maybe there's a different kind of consensus algorithm we could consider, but at least if you're talking about this sort of one. That block, that total time that it takes to produce a new block, one of the critical things, too, is that not only is one block production typically necessary in order for a transaction to clear, because we need the transaction to go into one block first before there's any chance the transaction can clear. But actually, in most of these systems, you typically have to have at least some tie-breaking rule and or some kind of other rules at play, which mean that usually most people, if you really want to clear a transaction, will have to wait to see not only that it was in one block, but that in at least one more block at a minimum got added to the chain, so that it's very clear that it got recorded.
First, because there can be tie break between transactions, but they can be tie break between blocks and between blocks on top of blocks and so on.
So that block,
so it just gets exponentially less likely that it happens, but it can always happen, right? So you need to wait a number of confirmation that is in line with the degree of confidence that you want to have.
And so the only reason I bring that up is because when you're starting to talk about scalability, there's two things that actually need to be taken into consideration with scalability. One is the transactions per second, but that's a throughput number. The other is the latency. In general, right? You don't want to sit around telling people that in order to, this brand new financial system that we're creating everyone has to wait 6 hours before they know if a credit card transaction. So there are if you're talking about cutting out middlemen, so we're not going to be having this intermediary who helps grease the wheels so that we yes, it takes 6 hours to clear, but I clear it right away because I've got money that'll back it or whatever. we're actually then talking about the total amount of time it takes to propagate, at least 2 blocks, possibly more, in order to actually clear a transaction. So that, not propagate, sorry, to produce, which is the longer time. We're actually talking about like at least 2x that time, probably at the best possible case. Was that a fair statement, would you say?
Yes. And actually, I would go further.
Okay,
I think those two are at their core the same problem.
Okay, yeah, please.
And so it's linked to the entropy of the system, which means, so you have different nodes and different network participants, and they have a view of the world that is slowly drifting apart.
Yes.
Right?
Yes.
Because, and you need to have operation that happens once in a while that's gonna, regroup them.
Yes.
And so this like spreading apart of like the view of the system that they have is what I call like the entropy in that context. And what you want from your consensus algorithm, if you want it to be scalable, you want it to keep the entropy small at all time as much as possible.
Yes.
Which means fast confirmation time as well.
Yes.
Right. So deep down, that's actually like the same. That's the same problem, and that's actually like the problem that we're attacking with eCash as well.
Okay.
So effectively, the conclusion that we come to. So let me describe like an alternative stuff that is promising first, because I don't want to present my stuff as it's the only stuff, even though I think this is the one that has the most potential.
Yes.
Another way of going at it is going full zero knowledge.
Okay.
Right? And some people are working on that, like Coda, for instance, where
okay.
They don't send you the content of the block, they send you the header, and they send you a cryptographic proof that the computation has been made on the header, on the content of the block, and has been verified, and you can check that proof fairly easily. It's based on zk-SNARK. I don't know if you're familiar with that cryptography. Well, so zk-SNARK is effectively a way to generate proof that you run some computation and that you ended up with some result.
Okay.
Right?
Sure.
That's not intuitive that you could do that, but you can actually do that.
Yeah.
And so the trade-off that you're making there is that doing the computation is not horrendously expensive, right? Because before, when you would add two number, no, you have to compute a cryptographic proof that you added those two number, right? So you need to do elliptic curve math where you would just be doing an addition before. So suddenly doing the computation become horrendously more expensive.
Yes.
But then you can send that proof to everybody, and everybody can verify the proof fairly cheaply in milliseconds, and be convinced that yes, you did the computation and everything checks out.
Okay.
So that's one way that people are exploring to solve that problem.
And just to be clear, the way that improves this is just because that way presumably you will still have to send the block, but people can start working on new blocks before they've received the old block at that point. Is that generally what, why does this actually improve anything would be, I guess.
Yeah, yes or no. So first, yes, people can start working on top of the previous block right away.
Yeah.
But the way those systems are built is that you don't need to send the content of the block. People that are going to send the transaction are going to attach with the transaction the information, like are going to attach proof to the transaction as well that the money was in the block and has not been spent. And
okay. So basically, what you're saying there is that if you design a system that goes with that kind of signature scheme, what you're going to be doing is counting on the actual person who initiates each individual transfer to attach all the state necessary to process that transfer with the transfer, so that you didn't actually need to know what happened in the previous block. Yeah. All you need to know is that somebody properly recorded the previous block, so that you know that this transaction isn't like
And
fraudulent.
they don't need to record the whole block. They need to record only the stuff that is related to them, right? So that puts, so the trade-off that you're making with that is that a lot of computation become horrendously expensive for the person making them, right? So if you want to make a transaction yourself, it's gonna be pretty expensive, though it's very cheap for everybody else. So maybe that's a trade-off that's worth it. But also, if you look at Bitcoin, for instance, if you have your key, you're safe, right? You can take a new computer that have never seen your wallet whatsoever. You enter your key in it, the wallet can scan the blockchain and retrieve everything, right? On those systems, you're screwed, right? Because the blockchain is completely opaque. So, and the second stuff is that you have to trust the cryptography, which seems to be okay, right? But the problem is if the cryptography is broken, it's not a given that you're gonna know it.
Okay.
Right? Because if I find a way to break the cryptography and I don't disclose to anyone, I can probably create money out of thin air.
Because no one's really checking it.
Right?
Okay.
So that's the trade-off that you're making. And some people are working in that direction. I mentioned Coda. There are a few other stuff, but that's one direction people are exploring. The direction that we are exploring is leveraging another consensus algorithm that is called Avalanche. There is also like another cryptocurrency that is called AVAX that leverage that as well. And this is a consensus algorithm that is fundamentally different from the Nakamoto style consensus.
Do you want to go into a little bit of detail there on it then?
Yeah, so I don't know how deep we want to go because it's like, fairly technical, but effectively the basic idea behind it is that you're going to have nodes that talk to each other, right? So say you receive a transaction, you want to know if it's good or not, right? If everybody accepts it or not. So, like a good set of the participants, you're going to choose a few of them randomly, say, 8 or 10 or something like that. And you're going to ask those 10. And you're going to be like, okay, do you think this transaction is good or not? And, maybe like 10 of them, they say yes. Then you increase your confidence score that this is yes, right? And if 10 of them say no, then you increase your confidence score that this is no. And you have your own position as well, right? So, yeah, like I took a shortcut here that I should have taken.
So just for the record, most people who watch my channel are very technical. So you can be as technical as you want. The only thing that you can't really assume is that they know the cryptocurrency
the specific technology of cryptocurrency.
Because they're probably watching this because they haven't really looked into cryptocurrency yet. But if you explain something technical, that they will like that. They will like to hear the actual explanation, not the Wired magazine explanation.
Okay, so the idea is you have the transaction and you have your opinion if it's good or not. Right? And you have a confidence score in your decision, right? So maybe I received the transaction, I think it's okay. And well, at the beginning, my confidence is very low. And so I'm gonna ask, like 10 other nodes on the network and be like, do you think this transaction is okay? And let's assume that I think it's okay. So if those 10 guys that tell me, yeah, it's good, or maybe like 8 over 10, there is some threshold there. But if most of them say good, then I increase my confidence score. And if most of them say no, this transaction is not good, then I reverse my position. I say, no, I think it's not good. And I reset my confidence score to 0. All right. And if, I get like a mixed response, like some of them think, then I just like discard that round and I try again. Okay. And now all the nodes are doing that as well.
And when you say, sorry, just to clarify there, when you say, and try again, I assume you mean you are trying to do the same transaction, but you've picked a different set of servers to ask, or what does try again
I'm going to select a new random set of say 10 nodes. Obviously, like all those parameters, you can change them and you get different trade-offs between, how fast those things converge and how many fault tolerant you want to be and all of that, right? Like
Yes.
those parameters, they can be tuned, but let's say 10. So you ask 10 and yeah, either way, like no matter what the result is, either you flip your position or you increase your confidence, or it's just like unconclusive, you do it again. You select another random set of nodes and you ask them the same question and you do it again and again and again.
Okay.
And at some point, your confidence is going to be very high. And at that point, you say, okay, that confidence is at a level that I think, the network has converged and everybody is okay. And it's quite remarkable that this system converged very, very quickly with very, very good properties. I don't know if some of you guys played Age of Empire.
I'm sure some have, yeah.
Yeah, so in Age of Empire, there is one unit that is a priest, and the priest doesn't do really anything. It's just pray, and when it prays next to another unit, it eventually converts the other units to his side.
Okay.
And so one thing that people have been trying for fun is like, what do you do if you make like 2 army of like 100 priests and you smash them against each other?
Yes,
and this is effectively what this protocol is doing.
Okay. Okay.
Right? Because every time you say, yeah, I think this transaction is correct, if enough people ask you, eventually you're gonna convince some of them. And even when the things start at 50-50, because you have random sampling, there is some noise that is going on there, right? So it's gonna flip one side or the other, and when it starts flipping one side, it's exponential, right?
Okay.
Because the more nodes think that it's valid or not valid, then the more round are gonna be conclusive toward that response, and then the more nodes are gonna be convinced, and you have like a snowball effect, right?
So can I just ask a clarifying question here, because I apologize. I didn't know about this scheme, so I haven't read about it beforehand. So just to clarify what is meant by asking if a transaction is good. So is the idea that this underlying system would generally have all of those nodes are sort of keeping track of something similar to what's in Bitcoin, meaning a signature chain for a particular piece of cryptocurrency, and then when we see a new transaction, we go, oh, is that a proper append to this chain, or is it like basically a double spend? Or are we talking about storing something else? Because obviously the consensus algorithm can be separated from these, but I'm curious for just to understand the whole package. That was question number one.
Yeah, exactly.
And
so
I have one other question just to put them both
okay
in there, because I think you can handle both at the same time. The second question is, I didn't hear in there how the network actually advances. So once I determine that people do think a transaction is okay, do I broadcast that fact, or do I wait people to ask me for it to propagate? Does that make sense?
Yes.
Okay.
So I'm gonna answer the second one before the first one, because
I figured,
it's easier in that order.
Yeah.
So what's gonna happen is that once you reach a certain confidence score, meaning you have done like a certain amount of round where everybody agrees with you all the time, right? You sample random people. You can be confident that either everybody has already finalized to that result, or the people that haven't, they are gonna finalize toward that result.
I'm not.
And you can put a probability number on that, depending on your parameters. So the math are in the paper, and you can choose that parameter to be like completely absurd, right? Like you can choose 99.9999999%.
Oh, okay. I'm sorry. So let me just see, because I didn't was trying to say it. So is it also implicit though? Because I didn't realize this part of it. From what you're saying, I'm just guessing.
Okay.
So is this system also like Bitcoin in that when someone wants to make a transaction, they broadcast it to all the nodes?
Oh, yes.
Okay, that was the part I was missing. Okay, yeah, I see.
So actually,
okay.
This system is a consensus algorithm, right? So you can build it on top of all kind of weird chains.
Yeah.
And this is what actually the AVAX guys, they are doing. They have a chain that works with an EVM, so that works like Ethereum. They have all kind of different chains that do all kind of different things. What we do is a bit different, because we have a chain that is extremely close to how Bitcoin works. The base chain is extremely close to how Bitcoin works. And we use that on top of it. So in our case, everything that you know about Bitcoin still applies. And actually, you can connect to our network without knowing anything about Avalanche. And then you get none of the benefit of it.
Right.
But you can still understand, what the chain look like and parse the transaction and understand their meaning and all of that.
Gotcha.
It's and that's one of the design decisions we made, because there is a lot of software out there that is already made for Bitcoin, and all that software, they can work on our stuff. And so that's one reason. The second reason is Bitcoin as a property, the consensus algorithm of Bitcoin as a property that Avalanche doesn't have, and that I think is important.
Okay.
Is that Avalanche is it's a live process, right?
Mm-hmm.
So when you're part of it, you participate, you get to the result with everybody, great.
Yes.
What happens if I'm a new node and I connect to the network? Then I'm gonna ask people, and they're gonna tell me something, but is it the real deal? Like, anyone can come up with anything and give it to me,
right.
and just,
and know.
I have no way to verify any of it, right? Because at some point, like, one of the state of the system is who are the different nodes that I should query, right?
Yes.
And so I have no way to bootstrap myself into that system, except, like, getting the information from somewhere that I trust.
Okay.
Whereas with Bitcoin, you have this blockchain that is like an objective artifact that I can, go through, get to the end of it, know what the set of node is, and start going from there. So this is why we are not ditching the whole stuff, because it has properties that the new stuff doesn't have. But the new stuff has also pretty cool properties. First, it's asynchronous, right? So I can finalize a transaction or another at different time. They don't need to wait on each other anymore, right? So from a scalability standpoint, that's very, very good. I don't have to, because the blocks, they kind of like create like a bottleneck effect, like, where you do nothing for 10 minutes and then boom, you need to do a ton of work, and then you do nothing again, right? So that spread the load over time. And the second one is that it's extremely quick to come to a result. Like, typically it takes less than 2 seconds with nodes scattered over the world. Obviously this is not a guarantee, but you get less than 2 seconds, like, 99% of the time or something like that. It's very quick. It's probably like quick enough for, like, our target was 3 seconds, less than 3 seconds. So this is good for us. And why we went there? Well, it's from the statistics for payment processors. So what happened is that payment processors obviously have done a lot of research about that. And what they conclude is, like, when the payment take more than 3 seconds, people are, like, a bit irritated by it. It's like bad user experience. When it's less than 3 seconds, they're okay with it. They kind of expect that to take that long, right? But after 3 seconds, they start to be irritated. And after 5 seconds, they think that it is broken.
Okay.
At least for a while, right? Is it working? No. Oh, okay. It confirmed, right? But there is that moment where you're like, is it broken or what, right? And it happens about 5 seconds in. So we were like, we want something that is as fast as possible, but really, like, our target is 3 seconds, less than 3 seconds. And with that technology, we get less than 2 seconds most of the time. So that's pretty good. And so what happens when you have that is that over the 10 minutes in between blocks, the node run that thing. And so when the time for the block arrives, they kind of all agree on what is in the block. Like, there is just like the fuzzy edges of the past 2 seconds when the blocks come that you don't know about, right? But everything else you agree about. And even, like, if the block doesn't correspond to that, you can ditch it, right? And because everybody is going to agree on like 99% of what the block is going to look like. If those 99% are not what you expect, you can just offend the block, like, just not accept it. And so when you do it that way, you avoid that problem of doing nothing and then doing a ton of work as fast as possible, because that time needs to be very short, because it needs to be negligible versus 10 minutes. and then going back to doing pretty much nothing for 10 minutes.
Yeah.
So that gives you tremendous scalability properties, and that also gives you very fast confirmation time, because at the core, the two of them are the same problem. The two of them are like the consensus algorithm taking forever to make a decision. That's where it comes from.
So I guess that this is somewhat surprising to hear in a way, because one of the things, I mean, maybe this is something that is just a bad artifact of the way crypto is typically discussed and how it's usually synonymous with blockchain. In other words, the idea that there has to be a series of blocks that are chained together as the important part of the underlying system. One of the things...
It's strange, isn't it? Because one of the things that I've been keeping saying is that, like, blockchain is probably the least interesting part, because we've been having those since way before Bitcoin. And I'm sure like all of you guys are using one almost every day. Like if you use Mercurial or Git, like you use a blockchain. There is nothing special or magical about it. This is not something that is new with crypto or anything.
Yeah.
So really, that's not the interesting part. As you mentioned, the interesting part is like, how do you solve the double spend problem?
And so it's interesting to hear this, because in general, I would say what you described as a consensus algorithm, when I first sort of like, heard about these things, I don't know how many years ago it was, my first thought was, that sounds like a stupid solution to this problem. Why wouldn't you just use a standard consensus algorithm such as the one you just described? Meaning, why wouldn't I just use something where I simply ask peers and we come to a consensus using a Paxos-like scheme? Because it's unclear to me why spending a lot of time solving a hash problem improves anything, especially when you start going, which you immediately heard like soon after Bitcoin, that the main problem was transaction latency or throughput. I'm like, well, yeah, because it's designed to be slow. So I guess what I would ask, first of all, I'd say like, so I probably don't have that many questions for you about that, because that's how I think I would have proceeded, is to try to find a system like the one you described.
So may I interrupt you, because I think there are very interesting stuff in what you said, and maybe some of those are like the implication of some of those are not that obvious. So first, like this Avalanche paper, it's from 2018, right? So that's something that is very, very new.
Okay.
And so there is something that is fundamentally different with, traditional older, I'd say maybe like classical consensus algorithm like Paxos.
Yeah.
The main difference that Nakamoto consensus and Avalanche are going to have with Paxos is that for stuff like Paxos, you kind of need to know who the set of participants is, and it also scales not very well in the number of participants.
Well, because it's an actual consensus algorithm, not a like eventual consensus algorithm or a statistical one. So, it has worse properties because it's trying to do something.
Yeah, but here is the deal. Like Paxos would be very good if you wanted to make some kind of alliance between, say, PayPal and MasterCard and Visa and Alipay or something like that, right? Because all those guys, they know each other, the set of participants is known, and you can set up the system, and that would work tremendously well.
Yes. But
there is an assumption here that doesn't work for crypto, is that for crypto, you want the set of participants to be like anybody, right? And Paxos doesn't provide you that. And where Avalanche actually is kind of a breakthrough is that it takes something that looks like Paxos, but instead of being an actual consensus algorithm that's gonna come with an answer yes or no, it allows the same probabilistic property that you get with Bitcoin, which allows you to have an open set of participants rather than a closed set of participants like you would have with Paxos. It also allows you to be more scalable, right? Because I think Paxos is n-squared in the number of participants, which is a bit of a problem. This is n log n in the number of participants. So you can get to humongous number of participants without degrading the performance of the system.
Yeah, I mean, effectively, like from what you described, and obviously I'll go read up more about it. But it's basically like statistical Paxos. It's like, look, we don't
Yeah, yeah,
need a
yeah.
hard answer, and if we give up the fact that we're not going to really know exactly the answer, we can just be reasonably sure of the answer to our own statistical needs. Then hey, now we don't have to do the full problem, right? It's the randomized. I mean, a lot of times you see n squared problems solved with a randomized algorithm that gets you to n log n. This is something we do in geometry. It's something people do all over the place. This is like sounds like that basically. I mean, if that's a fair description.
I think that's a fair description. Yeah.
Um.
Yeah, that's statistical Paxos. Yeah. In
Yeah.
obviously, like the details are,
Yes. Yes.
there are a bit more details, right? But
Yes.
if you want to think it that way, that's an excellent way to go at it. Yeah.
Well, so that's great to hear. I'm thumbs up to hear that, because I'm like, that's what I kind of thought would be the right kind of answer, but I didn't know if anyone was actually doing it. So that kind of
Yeah. Well, the thing is, it's remarkably difficult. It's one of those stuff. Like once you read the Avalanche paper, it's actually remarkably simple.
right, but to come up with
And
how it would work, yeah.
yeah, it's the kind of paper like once you've read it, you're like, oh, come nobody thought about that before,
Yeah.
right? Like it's obvious once you read it, but actually, I can tell you for a fact, we were working on that problem when the paper came out,
Okay.
and we had a solution that was fairly similar, though it was worse in pretty much every way.
Okay. Gotcha.
So the idea was similar. The idea was to also use random sampling, but where we went wrong is that the Avalanche guys, they were like, we're gonna random sample everything and not give a shit. Like if we need to do something, we just random sample.
Gotcha.
And we went into, okay, if we do things that way, then in some condition we need to do random sampling. So we worked out the condition in which you needed to do random sampling, and it turned out to add a lot of complexity, and the property was no better than what is in there, right? And instead of adding all that complexity, asking yourself in what case you need to do random sampling, you just do random sampling all the time. And once you read the paper, you're like, yeah, like what kind of idiot we were. But that's that's how it happened.
So in some sense too, another positive thing that comes to mind about that to me, and again, I'm just assuming that this basically does what I had hoped, because like I said, this was sort of in my head one of my main complaints about everything I had heard about crypto, was that I'm like, the answer seems to be what you were just describing as the answer. I'm like, if you just want distributed transaction processing, what you want is a consensus algorithm that converges to the correct set of transactions. And this seems like a really bad one, right? Like I don't have any real complaints about Bitcoin from the standpoint of it solving the problem. It does solve the problem. It just seems to be a very bad solution to it, which was usually my complaint. So
but it has this archival property that I think is nice and quite important for something that is monetary. So the way we think about it is that I don't know if you've bought a house or like something like that, something fairly expensive that has a formal process.
But just to be clear, when I say bad, I mean the consensus algorithm, proof of work. I was like, proof of work seems like a very bad solution to this problem. I'm like, I'm pretty sure that's not the way you want to go forward with it. And especially when people start talking about, there's so many things we can do with blockchain. They were talking about that. And I'm like, that just sounds like using a bad solution and propagating that bad solution. I'm like, if what you need is distributed consensus, I pretty much can guarantee you this will not be the one that you want. So it's nice to hear about more. But anyway, sorry, continue.
Sure, but up to 3 years ago, this was actually the only solution, that solution and variation of it, right? Like this whole stuff that we're talking about right now is really out there for 3 years. So that's something I think we're gonna see a lot more of. But so yeah, I was saying, like, when you buy a house, so you discuss with the people selling the house and you agree on the price and whatever, right? Like you do all the stuff and it's fast and all of that, right? And then you go to a notary and you go through some kind of formal process that is annoying, that take much longer. Everything that you have in that process, actually, you already agreed upon beforehand.
Yes, yes, yes.
And the reason you have that process is because you want to have a record of who who owns what house, right?
Yes.
Which house. And you want to be able to verify, like if 5 years later someone has a question about it, you want to be like, okay, like this guy bought the house at that point in time. And the notary aspect of it is not done well by stuff like Avalanche, right? So this is why we use effectively Avalanche to make the decision, but we still keep the blockchain so that someone can disconnect from the system, come back later, or just a new participant come in the system and look at what the state of the world is and have a record of that.
Well, how would that work though? So I mean, this isn't just because you brought it up. This isn't really a question I would really have because I'm not sure. To me, it would matter that much. But because you brought up that aspect of it, if the basic idea is I have all the nodes in the system that are currently working with an Avalanche consensus model, but under the hood, I would like them to store complete transaction histories. Presumably, that would imply that those complete transaction histories do not look similar, because I only know which transactions other people I asked said were okay, so I know they're valid transactions, but I may not put them in the block in the same order. I may fill up different blocks with them potentially, unless you're also somehow validating the block. So do you understand what I'm asking there? I'm not sure I understand how the blockchain is maintained inside an Avalanche system, because you're only asking about whether you should put transactions in blocks, but not what order they went in or how, or which block even.
Yeah, so one of the things that we change versus Bitcoin is that there is a canonical ordering in the block. So all those questions, they just go right out of the window.
Okay.
If you know the set of transaction in the block, you know the block.
But I don't know which block. Like, what if I fill my block up and say, okay, now this block is done? Is it just that, there's no such thing as a block that's done because if later transactions turn out they would have sorted into that block, I have to...
No, there's an actual block that looks like a Bitcoin block.
So let me try to explain my question then more specifically. So I am implementing a node that is trying to keep a Bitcoin-like blockchain, and I'm using Avalanche for consensus. So what I know is I know the set of transactions that are approved. That's generally what I know, right? Because I'm getting transactions from people who are just spamming them at me, and I have no idea if they're correct. And then I'm taking those transactions and saying, all right, I'm going to start asking counterparties in the system.
Well, first you're gonna validate them, right? Because if they are invalid, like the signature doesn't check or whatever, you ditch them. You don't ever run the consensus algorithm.
But so when I say spamming, I mean I don't know if they're double spends or not. I can trivially reject ones that are like not cryptographically signed. But for all the ones that are cryptographically signed, they might just be people trying to cheat. So now I got to figure out, put them in there. I ask, I shouldn't say counterparties because that's a financial term. I ask other nodes validators in the network. I say, like, what do you think about these? I get all the ones where I reach a certain confidence level, and I start to put them in the block, and I sort them by some thing because you said there's canonical order. So I put them in the canonical order, I put them in the block. Now I get a new transaction in, and oh, wait, that transaction really should have gone in this block because it would have sorted ahead of the one that I did put as the last one in that block. So now that block is no longer really finalized. Just want to be, is that did I correctly describe a thing that could happen first before I get to my question?
So as time goes, everybody like fill the block effectively, right? And at some point, the miner is gonna find the actual block, and the actual block is gonna look very closely to what everybody think that the block is gonna look like. You know what I mean? It's not gonna be exactly the same, but it's gonna be very close. And
wait, so you're still running proof of work underneath?
Yeah.
Oh wow. Okay, so you're doing Avalanche for early consensus, but then
we call it pre-consensus, but yeah.
Why?
Because if you do just Avalanche, you cannot have a new node connect to the network and know what the consensus is.
But why couldn't it just do the exact same algorithm?
Because it doesn't know the set of participants.
Well, it needs to know the set of participants to ask for the chain.
Well, except it needs to find one honest participant, and then it can have the chain.
But if it finds one honest participant, couldn't that participant just be honest about the set of nodes in the network instead of the chain?
Yeah, but you don't know.
You don't know what?
Well, because you can measure the weight of the chain. This is something that is objective that cannot be faked.
For someone who's just joining the network?
Yeah, I can see like this chain and that other chain, like this one has more proof of work in it than the other, right?
So you're talking to multiple people and asking them multiple
Well,
people.
this is what happened when you connect to the network. You're gonna connect to so there are different methods that the node use to bootstrap itself. Typically, there are DNS seeders, so that are gonna be like nodes and that are connected to a DNS address, and you hit that DNS and you get like a set of peers. There is like a set of peers that is bit into the node, and then once you connect to various people, you ask them for more nodes, and you try to connect to more and more people that way. What happens with, and this is something that is actually common to all the proof of stake system, because the system is self-referential. You can be provided two chain and they are equally as good, and you have no way to know which one is the chain that everybody agrees on. And on those two chains, the set of validators are going to be different, right? So you have no way to run any kind of consensus algorithm between the two to know which is the right one.
So,
right? So if you're a new node to the network, you connect to me, I can tell you, oh, this is the state of the system, and I happen to own like all the money in the world, right? And you're gonna connect to someone else, and they're gonna tell you something else, right? Probably the honest truth that the money is spread out between different participants, right? And you have no way, obviously this is caricatural, so here you'd have an heuristic to know that maybe I'm trying to screw with you, but in the absolute, you have no way to know which one is correct, because all those validators, in my view of the world, they have no money, right? They are not like valid participants to the network.
So I guess not to belabor this point too much, but that's sort of what I do in technical interviews, because a lot of people just like to kind of move through them quickly, but I like to go like, wait, no, I'm not sure. Mm-hmm. So because, like I said, I'm interested in this kind of algorithm because it's the kind of algorithm, the Avalanche part is the kind of algorithm that I actually was thinking is sort of the way that this kind of system should be going. I just want to understand why it would still require Bitcoin underneath. Suppose, so I want to separate two things so we can talk about them very clearly. One is, how do I know whom I should contact, right? Like I should be sending messages to whom, right? That's a list of IP addresses or something like this that at startup, I need to at least get some, because if I don't have anybody to talk to, I can't even start the process, right? So that's one problem. And then a secondary problem is basically startup. So once I have some set of nodes I can talk to, how do I get myself into a state where I can actively participate in the network, since in order to do that, I need to be able to have some understanding of what would make a valid transaction and what wouldn't from the point of double spending. And with no history, I can't really do that. So would you agree that those two problems are sort of, they're separate problems, they're related, but they're two different problems that I have on startup?
Yes, but I think there is one aspect of the problem where you need to discover the peers. That is important, that I think you skipped a bit over.
Please, yeah.
It's like, like in practice, it's very easy for someone to spin out like a gajillion nodes, right?
Yes.
And you cannot really trust that the node that you're connecting to are going to be honest in any kind of way with you.
Yes.
Right? Because in practice it is, but it is because you don't assume that it is. If you start assuming that it is, then everybody is going to start a bazillion node to screw with you.
Yes.
Right? And so the main difference is that if you are in a world where you only have Avalanche, you are kind of pre-assuming that you have a certain amount of honest node in your connection, right? Like you would need that to bootstrap yourself. Whereas where you are in a model like Bitcoin, you need to have one honest node. If you can find one honest node, you're good. You're gonna find the reality of the situation.
But why would that be? Because if I have a Bitcoin
Because
blockchain, there's
yes.
nothing when I just connect to a network. If you say that, well, you only need one honest node, well, okay, so suppose the set of IPs that I have to work with includes one honest node and a few dishonest nodes or something like that.
Mm-hmm.
Each one of those nodes can send me a completely different blockchain. How would I have any idea which blockchain was the real blockchain?
Because you can compare the proof of work that is contained in each chain and see which one has more.
But that doesn't mean it's the real one. I could have just been falsifying the blockchain the entire time by having some computers that do proof of work on a fake blockchain, and then all I do is send that one out instead of the other one.
Yes, but when you do that, you get fake reward, right? So you are throwing a lot of cash through the window.
So the idea is just like, okay, the proof of work is just increasing the cost of producing a fake blockchain. So we assume that people would just...
Yeah, but in practice... Yeah, but in practice, it's increasing the cost to some extent that it's actually like pretty...
Yes,
yeah. Not only is very unlikely that someone do it, but it's not something that you pay and then here is you have your attack, right? Like this is a cost that you need to incur on an ongoing basis, yes. Right? And so maybe someone is going to be able to do that at one point in time, but they are not going to be able to maintain that, like forever. And so the assumption, like, so, we choose the parameter in our system in various ways. And what we assume is that someone is not going to do that for more than a few weeks.
And so is the assumption then too with something like Avalanche that when you ask one of the peers in the network to validate a transaction, like when you're asking, you received the transaction, you want to know if it's a double spend or not, you're asking around saying, hey, is this a double spend, is this a double spend, is this a double spend, to increase your confidence, is the assumption that each one of those messages that you send to check about the double spend is also asking for some kind of confirmation that it involves the fact that that actor was not a fake node as well? Like how does that part work? Because
yes,
if the
exactly.
idea is that everyone can spin up these nodes, how is that part being handled? Because do you see what I'm asking?
Yeah, absolutely. And I was actually starting to infer from your question that you wanted to go there because I realized that it was not explained at all. Okay. Because it's actually not explained at all in the Avalanche paper. It's assumed that you use an external mechanism to do that, but you need some form of what we call Sybil resistance. Okay. Right. So it comes from a Sybil attack. In security, a Sybil attack is when an actor pretend to be like many different actors to do something, right? So for instance, if you were just to connect to random node, as I explained, without any kind of Sybil resistant mechanism, well, someone can start a million node, right? And then statistically speaking, you're only gonna connect to that guy, right? And effectively that guy owns the network. And it's not that expensive with like VPS or whatever to just like have a bazillion nodes.
Or like botnets, are now,
or botnets or whatever.
Faking responses.
Yeah. So you need a form of Sybil resistance, and typically it's gonna take the form of proof of work or proof of stake or proof of something, right? Like because now you want twice as many nodes, you need like twice as many proof of whatever. Like this is an interesting stuff because Nakamoto consensus doesn't imply proof of work per se. Like proof of work is the Sybil resistant mechanism in Bitcoin, effectively, right? And you could do one with like proof of whatever else. And actually people have made all kind of system with proof of all kind of different stuff. And And the reason you need a proof of something is because you don't want to have a Sybil attack on your network.
Yes.
And so the way both the AVAX guy and we are doing Avalanche is by using proof of stake.
Okay.
Meaning that you need to prove that you own some coins to be able to be considered like a node that you can pull. And actually, like the probability is not completely random, as I explained. It's actually weighted by stake, right? So if you have twice as many coins as I have, you are twice as likely to be chosen randomly, if that makes sense.
It does make sense. Yeah, sure. So you've got to effectively, if you imagine picking a number between 0 and 1 to determine which peer you're going to go to, each person gets their percentage of the outstanding coins worth of range in this distribution. And so I look up who that would be, and that's who I pick.
Yeah, okay. And actually the algorithm is not exactly like that, but fairly close to that.
Yeah. So, okay, I guess... So one problem with that is it does start to make this more complicated. And so, you know, what do you think?
Yeah, so wait. This is why I think this is why the problem that I was trying to explain before becomes more clear now. Because now, if I start serving you a different state of the word, the state of, you know, acceptable validator is going to be different as well, right? So you have no way to know which one is correct. Right? Because proof of stake is inherently self-referential. You use data from within the system to do your Sybil resistance. Whereas proof of work is not self-referential. It uses an information that comes from outside of the system. And this is where the difference is.
So I guess, okay. So I guess what I would say is I'm half in and I'm half out then, because the fact that it still needs to maintain the proof of work underlying blockchain does still seem like there's fat to squeeze out of the system here.
Yeah. And I have good news for you.
Okay, hit me. Yeah.
I have good news for you. Because you run Avalanche, 51% attack are like almost impossible to run.
Okay. Because it's a probabilistic 50%, which is different, I suppose. Because which one you're picking is moving, so you'd have to have 50% of everyone's probabilistic selection, which is like basically impossible, right? That's like 100% in some sense.
I don't think so, but I'm not sure I understood what you're getting at, so maybe.
So because I am taking a random sample of the people who I'm going to ask, the chance that I end up with over 50% of the people I ask saying something actually is much harder to do if all the nodes are randomly picking.
Yeah. So you would have to not only have more than 50% of the hash rate, but you also would have to have like more than 50% of the validator effectively, or convince more than 50, which end up being much more difficult to do. And plus, if you do that, you are gonna make everybody 50 rich in the process. So please attack the system that way. Please. Well, because you're gonna have to buy all the stake, right?
True.
So you're gonna shoot the price to the moon. So actually, if someone tries to attack the system that way, I'm not even sure that people are gonna be that desperate about it.
Well, when you try to actually go to cash it out, it might be a problem. But
Yeah.
Okay, so I guess. Well, this has been really good because it's been interesting hearing about that stuff.
So wait, to make sure that we conclude that point, because 51% attack is so much harder to do, the whole system can live by with like an amount of work put into it that is way below what it is for Bitcoin, for instance.
So the proof of work amount can be turned down, basically, like it can be easier hashes, is what you're saying?
Yeah. You don't need the same level of hash to have a comparable level of security. Like you could get by with level of hash that are way lower. And actually, our system, our system is way less valuable than Bitcoin itself, and it uses the same proof of work, right? So if the Bitcoin miner wanted to mess with our chain, they could, except that they can't, right? Because their block is going to get offline if they do that because of Avalanche. So we can get by with a fraction of the proof of work that Bitcoin is using and still have a comparable level of finality. Actually, the finality is much faster.
Okay, so I think I've got basically the model that you're talking about here, although I'll probably want to read up more about it afterwards just to like get it clear. But so let's step back just for the conclusion of the interview, because we've gone for a long time, so I don't want to keep you for an infinite amount of time. So I just want to like go over a couple things then here. So first of all, if we now step back and say, what, in practice, what does this actually get us, right? So if we switch to a model like this for doing finance, what does this actually get us? I'd like to talk a little bit about that first, because I also want to validate that part. Now, the reason I'm less interested in validating that part is because at least, like, it sounds like to me from talking about what, kind of like the way you're working on it, I don't see any particular reason why we shouldn't have something like a decentralized currency of this nature in general, right? So the lofty claims aside, getting a good technology for distributed consensus about transactions, I'm into. Like it's just a technical problem that's good to solve because we know we need to do it, and having a good underlying system would be good. There's nothing great about MasterCard's system or anything like that where I'm like, oh, they've solved the problem so well, why bother, right? So I'm into that solution. I'm not sure, based on your description, it doesn't quite get as far as what I would want, but at least it's like, okay, there are people who are working towards getting something more sane as the underlying model than the original Bitcoin model, which I never thought was really all that good. So there's that. But now let's step back and say, okay, so suppose you keep going down this route and you get to something where maybe you even figure out a way to get rid of the proof of work thing altogether, and it's just like, we've got this nice distributed consensus protocol, we've got the probabilities under control, it statistically converges pretty well, everyone's happy with it, it's working, right? What do we actually get from this? Because it's one thing to say we should just do that because it's good to just have this system and we know we need it, so we might as well have a good one that was engineered well and engineered with the use cases in mind that exist today, rather than the use cases that existed in 1970 or whatever, which is more like, what we're using in banking today. What do we actually get, though? Because there's also the question of, did we actually get anything from that extra? Which is not to say we shouldn't do it. It's just to say, what actual benefits do we think we might get to sort out the lofty claims from things that might actually be real benefits that someone like me who wants to ask hard questions about it might agree we'll actually get, as opposed to the things that are like, it will just be utopia and everyone will have all the money and it's great.
Oh, we get NFTs out of it. That's really the...
Okay.
No, more seriously, I think we get digital cash out of it. I think that's really like the most important stuff. And I think cash is something that we take for granted, but it's going away. And it's something that without that technology, we have no way of doing in an electronic form. And I think this is a pretty big deal. No. I think this is probably a bigger deal than most people think, because if cash goes away, 100% of your money is dependent on someone else being okay with you spending it. And the consequences of that are like pretty staggering potentially. So and actually they are in some country. I mean, it's almost, I don't want to say perfect because it's really bad for those people, but it's very interesting what happened in Lebanon last week, because it's not something that we planned, because we discussed talking together like before. Before that, so the timing is like almost spooky. But last week, most of the bank in Lebanon closed, right? And people literally have, like, even if they have money in their bank account, they cannot spend it. Like that means they cannot buy food and whatnot, right? Like that's a really, really bad situation to be in. And I want people to think about that. Like, what would you do if your credit card doesn't work and and you cannot go to your bank tomorrow, right?
So I guess that's exactly
I mean,
what
like
I.
I have
Oh,
40
sorry.
euros in cash right now, right? About that, right? So I'm gonna last for a few days if I'm careful, but then after that, what do I do, right? Um, and and all of that depends on someone else being happy with you during the writing, right? So those people, like once cash is gone, which it, you know, with more and more stuff moving electronically, it looked like it is.
Yeah.
Those people are gonna have a leverage on your life. Like, you think the state and the police and the military have leverage on your life? Well, look at the people that control your money instead of you.
So I guess that is something I'd love to get into if you don't mind spending a few more minutes on it.
Mm-hmm.
So I want to really try to drill down to, will something like a distributed consensus system actually solve that problem, or does it just appear to solve that problem, though? Because at the end of the day, we still have the situation where, there are governments, there are police, there are laws. Cash has a certain property, which is that you don't actually have to do anything visible to any third party to use it. I can literally go to a grocery store, hand them the $10 bill, and they accept it, and almost nobody can actually see that transaction. But anything that happens in digital currency is visible to everybody. So the question
Mm-hmm.
is, what is the likelihood, or what are the technology requirements that you think will be in place to prevent the same sorts of things from happening with digital cash? Because they're not one-to-one equivalent, and there's crucial things there that need to kind of be addressed. Does that question make sense?
Yes. The thing is, to answer that properly, we would probably need like another full hour. That's like a very
Should we do another one someday?
if you want to,
Because I mean, we can
I'd
do
be
it
up
now. But
for
if
it.
you're tired, if you want to take a break, we can just do it some
Right
other
now
time.
is not ideal because it's starting to be late here.
Sure.
But if you want to do another one later on, I'd be up for it.
All right. Maybe let's do that then.
But
Do you want to make it a two-parter?
okay.
Okay. Well, I think we've covered all the. There was a bunch of good tech stuff in there, so let's just call that one done, and we'll try to schedule another one where we can talk about, will digital cash work or won't it, and if it will or won't, what are the technological bullet points basically that will determine that outcome?
Mm-hmm.
Because that'd be great.
That sounds good. If you want to go there, I think there are a few, but I think most of them are actually not that technical.
Cool. Um,
I think as far as I can see, the major, like, there are technical solutions. They are complicated. This is why I was saying like we probably need like another hour to
okay.
get into those.
Okay.
But I think that the technical solutions are okay. I think that like the major order are gonna be stuff like volatility, for instance.
Okay. Well, yeah, let's do another one if you don't mind then, because I would like to get into those, and that's sort of the other half of the question, right? Is like, can
Mm-hmm.
the can the can this be made to work efficiently? And it's like, okay, what are the things that are going in that? We kind of talked about that, and then the other one is, does it matter at the end of the day if we have it or not? So, well. I guess what I would say is this has been great. Thanks so much for talking with me, and I would like to do another one, so we'll try to get that on the schedule. Can
Yeah.
you give people your handle, like what you are on Twitter, how to look you up, and also you mentioned the fact that you're working on a particular cryptocurrency, so which one that is and how to find it and all that stuff for people watching at home.
Yeah. So I'm Amaury Séchet. I go by Didalnix on pretty much every platform. Twitter, or my GitHub is going to be the same, or like whatever. Um, Now I've been working first on Bitcoin Cash, which probably most people know because it's everywhere now. So I launched that project. I worked on it for many years. Now I'm working on eCash, and to find about that, just e.cash is gonna be the place.
Gotcha.
um, and yeah, that's pretty much it.
All right. Well, thanks so much for talking with me today.
Thank you.
Have a good one.